Good evening everyone, I'm Mr. H. Thank you for joining me for this video. Recently we've been presenting just a few videos on rotation of conics or conic rotations. We'll be looking at a simple or relatively a good question here, analyze, and we have to look at this x squared plus 2xy plus y squared. We have to rotate the axis and eliminate this xy term in here and demonstrate and show what it is that we're actually dealing with. You know, if you look at this equation in terms of the angle cotan 2 theta is equal to a minus c over b, it's not too hard because things will cancel out in terms of zeroing out. You have a, c and a b. You'll have a 1 minus 1 over 2, you'll have a 0. 2 theta is equal to inverse cotan of 0, which is a pi over 2, and therefore theta is equal to pi over 2 divided by 2, pi over 4. You can't always expect things to zero out here and you end up always with a pi over 4. Sometimes it can become pretty complex and you can end up having an actual value over here, and that value complicates everything afterwards. Anyhow, we're looking at pi over 4, then we have these two formulas which will help develop the substitution coefficients. You know what they are. X is equal to, and then there's a y equals to. There are these two specific items here you have to put down. X is equal to x prime cosine theta minus y prime sine theta, and then y is equal to x prime sine theta plus y prime cosine theta. In all instances, sine and cosine are of that 45 degrees, pi over 4, and it'll always be 1 over root 2. It'll always be that. For this specific example, then you'll have a x prime over root 2 minus y prime over root 2. Here you'll have a x prime over root 2 plus y prime over root 2. You can combine this under a common denominator if you want, but this right here will have an interesting end result. You'll put everything in there and eliminate the xy term, everything into that initial equation. You'll have x prime minus y prime all over root 2, which you can write as you see over here, square plus 2 times x prime minus y prime over root 2. That's this xy component here. Then we'll have the x prime plus y prime over root 2 plus y square. You'll have an x prime plus y prime over root 2 whole square, all equal to a 0. You can essentially look at everything here in terms of the numerator line and the denominator line and work accordingly. You'll have a x prime whole square minus 2x prime y prime plus y prime whole square, plus I'm working just all the way across in this numerator because everything here will be over 2 in terms of a common denominator. Plus, when I open this up, I'll have a 2x prime whole square minus 2y prime whole square. The intermediate term will cancel because it's a conjugate, a minus b times a plus b, plus x prime whole square plus 2x prime y prime plus y prime whole square all over 2. All over 2 will multiply, cross multiply with that 0, and it'll 0 out. So it's technically the denominator is gone and everything equals 0. Think about it. These root 2 squared became a times 2, and that times 2 going across becomes a 0. This cancels out, this cancels out. Now look at your x whole square terms. You have a positive, positive, and a positive. You'll have a 4x prime whole square. Now look at your y prime squared components. You have a positive y square, positive y prime square, and a minus 2y prime square, which is cancelling all those out, and you'll just end up with this. X prime whole square is equal to 0 and x prime is equal to 0. What does this look like to you? It looks like nothing more than an x equals a type of a vertical line, but on the x prime y prime system. In the x prime y prime system, I have a certain conic, which happens to be here a line, and that line is right here. But that line here very well represents an axis, your y axis, but this right here will represent your y prime axis. And why will that be the case? If x equals 0 represents y axis in a regular coordinate plane, you were to rotate it by 45 degrees. Now this is going to easily represent your y prime axis, and you'll see it to be the case. Check this out. You have your regular x and y axis, but everything got rotated 45 degrees. When you rotated it, you developed a new set of planes. Here was your x prime, here was your y prime. But our equation here of this, after the xy term has been eliminated, our standard form is this: x prime equals 0, and x prime equals 0 is your y prime axis. So here is your, you can say, your graph. That right there is your graph. Now how can we reconcile this this boxed item and this. They are indeed equations representing the same graph, and I will show you that just for completeness sake. You know what, I'll remove all of this. You've seen all of this, we don't need to see it. Take that original equation x squared plus 2xy plus y squared and start plugging some values. You don't have to plug too many, we'll plug 3. When x is 0, in that equation everything zeroes out. You have a 0 plus y squared equals 0, y is equal to 0. When x is equal to a 1, what happens? You have a 1 plus 2y, 1 plus 2y plus y squared. Solve for y. You can do factoring, right? Y squared plus 2y plus 1 is a y plus 1 times a y plus 1 is equal to 0, y is equal to minus 1. So what, x is a 1, y is equal to a minus 1. So that part is done. Let's pick one more value, and how about we put when x is minus 1, what happens? When you put minus 1 here in places of x, you have a 1 minus 2y plus y squared is equal to 0. This right here will be y minus 1 times y minus 1 equals 0, y is equal to 1. So when x is equal to minus 1, y is equal to 1, and we have a good set of points over here, we can actually graph what the original xy system represented. The original xy system represents a graph as you're seeing right here, 0, 0, 1, minus 1, and minus 1, 1 right over here. That's my original graph. That is a graph of x squared plus 2xy plus y squared. It looks very much like this type of graph, doesn't it? Y is equal to minus x. That's what it really looks like to me. Anyhow, if you were to transpose this graph onto that, the graphs will be identical, except what the x prime y prime system has done is given you a new rotated axis, but that rotated axis with the y prime axis represents your original graph here of this equation right here. So you're seeing a transposition. This right here, x squared plus 2xy plus y squared is equal to this, which is x prime equals 0, which is your y prime axis. So that right there is the essence of this particular question, and it has been completed. I won't say any more on this, but that's it for this video. Thank you for watching. Have a nice day.